Welcome students. So in the sources of energy, we are going to see about wind power or wind energy, then tidal energy, then geothermal energy. Let's come to the wind power or wind energy. Wind power or wind energy is the use of wind to provide the mechanical power through wind turbines to turn electric generators and traditionally to do other work like milling or pumping. Wind power is a suitable and renewable energy and has a much smaller impact on the environment compared to burning. So this is how the layout of the wind power or wind energy. So this is the foundation and this is a tower and this is the blade and this is the hub and this is the nacelle, and this from blade is connected to the, and from this hub it is connected to the generator through turbine and the gearbox, and this is the control, and this is the yaw system which is used to rotate the full hub, and which is connected to the, and from this generator the cable is, electrical cable is connected to the electrical balance of electric system and is connected to the grid. And this is how the wind turbines schematic diagram looks like. So this is the central hub, and from this hub the three blades are connected, and from this hub the main shaft is connected to the gearbox transmission, and from this gearbox brakes is connected, and from the brake is coupled with the generator, and through this generator electricity is producing. Let's see the video how this wind power or wind generator is producing.
How do offshore wind turbines generate electricity? You probably know that wind turbines produce electricity from wind, but how do they do it? Let's take a look at this particular offshore wind turbine. Sensors on top of the turbine measure the wind speed and direction. They signal the yaw motors in which direction to turn in order to point the nose in the wind. The kinetic energy in the wind causes the blades to rotate. The rotor drives a low-speed shaft, and by using a gearbox, the speed of the shaft is amplified. This high-speed shaft drives a generator which converts kinetic energy into electricity. A frequency converter synchronizes the generated electricity to the grid. Subsequently, a transformer amps up the voltage before electricity is transmitted. It then goes through subsea cables to a substation to which several arrays of wind turbines are connected. At this substation, the voltage amps up even more to minimize transmission losses. Finally, it is then transmitted into the mainland power grid. From the main power grid, the energy can be used to power hospitals, charge electric vehicles, or simply turn on light bulbs. And this is how offshore wind turbines generate electricity. We hope you enjoyed our 60-second lecture. Would you like to know more about offshore energy? Click here to see more of our videos and make sure to click here to subscribe to our channel.
Now let us watch in video how the windmill and inside the windmill power plant. Now let's see the advantages of wind energy. So wind energy is renewable and sustainable, and it is good for the environment. It reduces fossil fuel consumption. Wind energy is free. Wind turbines have a small footprint. Both industrial and domestic wind turbines are available. Wind energy can provide power to remote locations. Wind turbines are low maintenance. Wind energy has low running costs. It can increase energy security. Even though we're having a lot of advantages, some more disadvantages of wind energies are there. So the wind fluctuates. During the wind fluctuates, we can't give the constant wind power generation. So wind turbines are expensive, so that the initial costs are expensive. So wind turbine pose a threat to wildlife. Wind turbines are noisy. Deaths of birds and bats that fly into the rotors. Now let's see the tidal energy, how it is working. So tidal power of tidal energy is the form of hydropower that converts the energy obtained from tides into useful forms of power, mainly electricity. Although not yet widely used, tidal energy has the potential for future electricity generation. Tides are more predictable than the wind and the sun. Tidal energy or tidal power can be defined as an energy that is the result of the moon and the sun's gravitational influence on the ocean. The height differences between high and low tides create tidal currents in the coast. Let's see this illustration. In this tidal energy, due to the sun and moon, earth and the moon's gravitational force, the high tide and low tides waves are created. So when high tide waves are created, while constructing a dam, so the water from this left side, it moves to the right side. Here its high tide is formed, so it moves from the left side to the right side, so that it runs the turbine blades, which in turn runs a generator which produce electricity. And in the same manner, when the low tide is created, the water from the right side is moved towards the left side, so that at same time it's run the turbine, which in turns run the generator which produce electricity. Now let's see the basic principle of tidal power plant. A dam is constructed in such a way that a basin gets separated from the sea, and the difference in the water level is obtained between the basin and the sea. So this is the sea and this is the basin. A dam is constructed in such a way which gets separated the basin from the sea. The constructed basin is filled during high tide and emptied during low tide by passing through the sluices and turbine respectively. So during low tide, this is the illustration of the low tide. So during low tide, the water level from the basin, it's emptied to the sea. While emptying, it's run the turbine. The potential energy of the water stored in the basin is used to drive the turbine, which in turn generates electricity, as it is directly coupled to an alternator or generator. The components of tidal power plants. There are three main components of a tidal power plant. First one is a dam or barrage, and the sluice ways from the basins to the sea and vice versa. First one is the dam and the sluice gates or sluice ways, which is used to move the water from sea to the basin and from the basin to the sea. And the powerhouse, barrage, dam, and barrage are synonymous terms. Functions. The function of dam is to form a barrier between the sea and the basin, or between one basin and the other in case of multiple basins. Tidal power barrages have to resist waves whose shock can be severe and where pressure changes sides continuously. The barrage needs to provide channels for the turbine in reinforced. The location of the barrage is important because the energy available is related to the size of trapped basin and to the square of the tidal range. The nearer it is built to the mouth of bay, the larger the basin, but the smaller the tidal range. A balance must also be struck between increased output and increased material requirements and construction costs. Tidal barrages request sites where there is a sufficiently high tidal range to give a good head of water. The minimum useful range is around. Let's see the animation of tidal energy, how this tidal energy is working.
Tidal power. Tidal power is a form of hydropower that converts the energy from the natural rise and fall of the tides into electricity. Tides are caused by the combined effects of gravitational forces exerted by the moon, the sun, and the rotation of the earth. Tidal plants can only be installed along coastlines. Coastlines often experience 2 high tides and 2 low tides on a daily basis. The difference in water levels must be at least 5 meters high to produce electricity. Tidal electricity can be created from several technologies, the main ones being tidal barrages, tidal fences, and tidal turbines. Tidal barrages are the most efficient tidal energy sources. A tidal barrage is a dam that utilizes the potential energy generated by the change in height between high and low tides. This energy turns a turbine or compresses air, which in turn creates electricity. Tidal fences are turbines that operate like giant turnstiles, whereas tidal turbines are similar to wind turbines, only underwater. In both cases, electricity is generated when the mechanical energy of tidal currents turns turbines connected to a generator. The generator produces electricity. Ocean currents generate relatively more energy than air currents because ocean water is 832 times more dense than air and therefore applies greater force on the turbines. Tidal power is easy to install and renewable, having no direct greenhouse gas emissions and a low environmental impact. Because the ocean's tidal patterns are well understood, tidal energy is a very predictable energy source, making it highly attractive for electrical grid management. This sets it apart from other renewables that can be more unpredictable. However, adoption of tidal technologies has been slow, and so far the amount of power generated using tidal power plants is very small. This is due largely to the very specific site requirements necessary to produce tidal electricity. Additionally, tide cycles do not always match the daily consumption patterns of electricity and therefore do not provide sufficient capacity to satisfy demand. That's tidal power.
Now let's see the advantages of tidal power plant. So it is free from pollution as it does not use any fuel. The tides are totally independent on nature's cycle of rainfall. This will also not produce any unhealthy waste like gases, ash, atomic refuse, which entails heavy removal costs. Another notable advantage of tidal power is that it has a unique capacity to meet the peak power demand effectively when it works in combination with thermal or hydroelectric system. Let's see the disadvantages of tidal power plant. These power plants can be developed only if natural sites are available. These power plants will be always located far away from the load centers. The power generated must be transported to long distance. This increases the transportation cost. The capital cost of the plant, that is rupees 5,000 per kilowatt, is considerably large compared with conventional power plants like hydro. The supply of power is not continuous as it depends upon the timing of tides. Therefore, some arrangements, double basin or double basin with pump storage, must be made to supply the continuous power. This also further increases the capital cost of the plant. It is interesting to note that the output of power from tidal plant varies with lunar cycle because the moon largely influences the tidal rhythm, whereas our daily power requirement is directly related to solar cycle. Now let's see the geothermal energy, how this geothermal energy is working and how it is useful for us. At a geothermal power plant, wells are drilled 1 or 2 miles deep into the earth to pump steam or hot water to the surface. You're mostly like to find one of these power plants in an area that has a lot of hot springs or geysers or volcanic activity because these are places where the earth is particularly hot just below the surface. Now let us see how this geothermal power plant is working. Hot water is pumped from deep underground through a well under high pressure. So from point 1 to 2, the hot water is pumped from the deep underground through a well under high pressure. When the water reaches the surface, the pressure is dropped, which causes so the steam spins a turbine which is connected to a generator that produces electricity. So this steam which is used to rotate the turbine which is connected to a generator that produce electricity. The steam cools off in a cooling tower and condenses back to water. The cooled water is pumped back into the earth to begin the process again. So after the steam get condenses in the cooling tower, it is again pumped back into the earth to begin the process again. Now let's see the video how this geothermal power plant is working.
You may have relaxed in a natural hot springs pool, or seen the old faithful geyser blasting hot water into the air in Yellowstone National Park. But have you ever thought of where all that heat comes from? Well, it comes from deep beneath the surface of the Earth, and it's called geothermal energy. And we can use it to generate clean, renewable electricity. Okay, here's how geothermal works. Heat from the Earth's crust warms water that has seeped into underground reservoirs. In some places, when water becomes hot enough, it can break through the Earth's surface as steam or hot water. This usually happens where the Earth's crust, or plates, meet and shift. In the past, taking advantage of geothermal energy was limited to areas where hot water flowed near the surface. But as geothermal technologies advance, we can leverage even more of these natural, renewable energy sources. Engineers have developed a few different ways to produce power from geothermal wells drilled into the ground. Have a look at this. It's a dry steam geothermal power plant, and it's the most common type of geothermal technology used today. Underground steam flows directly to a turbine to drive a generator that produces electricity. Pretty straightforward. Another geothermal technology is called a flash steam power plant. A pump pushes hot fluid into a tank at the surface, where it cools. As it cools, the fluid flashes, or quickly turns into vapor. The vapor then drives a turbine and powers a generator. A binary cycle plant works differently. It uses two types of fluid. Hot fluid from underground heats a second fluid, called a heat transfer fluid, in a giant heat exchanger. The second fluid has a much lower boiling point than the first fluid, and so it flashes into vapor at a lower temperature. When the second fluid flashes, it spins a turbine that drives a generator. The environmental benefits of this clean, round-the-clock, renewable energy source are substantial. Low emissions, small physical footprint, and minimal environmental impact. The few byproducts that can come up are often re-injected underground. Geothermal energy can also help recycle wastewater. In California, wastewater from the city of Santa Rosa is injected into the ground to generate more geothermal energy. Some plants do produce solid waste, but that solid waste may contain minerals that we can remove and sell, which lowers the cost of this energy source. The U.S. Geological Survey estimates that untapped geothermal resources in the United States, if developed, could supply the equivalent of 10% of today's energy needs and cut our dependence on fossil fuels. In fact, electricity generated by geothermal energy already provides about 60% of the power along the Northern California coast, from the Golden Gate Bridge to the Oregon state line. Geothermal energy, helping to push America toward energy independence and a clean, renewable way to meet our growing energy demands.
Now let's see the advantages of geothermal energy power plant. They're relatively environment friendly and they produce large amounts of energy. They result to stable. Let's see the disadvantages of geothermal power plant. They can't be built just anywhere. Only where the geothermal sources is available, there only we can construct the geothermal power plant. They can be expensive to build. They can cause environmental. Thank you, students. Thank you for watching this session. We'll see you in the next class.